Hello, everyone. My name is Agnieszka Szmelter-Jarosz. I'm representing University of Gdańsk and also PKA, two of the project partners in the CE4C project. Today, I would like to say to you a few words about our pilot in Gdynia. That is why I will present some few slides about that and will try to explain all the details about our pilot project. So this presentation was made by my colleagues and myself. So special thanks to our colleagues from University of Gdańsk, PKA and Kruch Railway Solutions Innovations for helping us to deliver all the results of this pilot project, very interesting results for energy flows simulation for a public transport operator in Gdynia. We would like to especially say thank you to Kruch Railway Innovations, our colleagues from Kruch who helped us to go on with all the simulations, gathering data, delivering all the scenarios possible for our pilot project, and also to analyze all the data we had to analyze within our pilot. I would like to say a few words firstly about general assumptions of our pilot and also what was the goal of the project. And then I would like to go to public transport in Gdynia, saying a few details about the specifics of Gdynia public transport system. Then we will go to developing digital twins and EFS, so energy flow simulation, which was our main goal in this pilot. Then we will go to results, and I will just present in a nutshell the results of very wide analysis of the data for a public transport operator in Gdynia for a part of transport network, in fact, and then I will sum up shortly all the results I will present, and these I will not present because of the lack of time. Our results were very vast. Going through our project, we delivered strategies for CE transitions, and for sure you know something about that since you are familiar with our other videos delivered by the colleagues from other project partners. Also, one of the goals of the CE4CE project was to deliver results for pilots in different cities to see if some solutions are sensible to be implemented or not. Our project was about energy flow simulation and also gathering the results for this very pilot and other pilots for our other partners. We delivered action plan for PKA, which is public transport operator in Gdynia. Gdynia is a part of the Tri-City. For your information, is one of 3 cities in the Tri-City near Sopot and Gdańsk. And PKA is a public transport operator operating in Gdynia and also in Sopot. Within our project, we were focused on presenting some KPIs as well for analysis, how to develop or how something was developed for public transport in Gdynia, but it is also applicable for other cities, and we presented some objectives, assigned targets for our city, and delivered some processes maps together to analyze KPIs and also to present the current values of these KPIs and also deliver some target values for future for our public transport system. However, it's not the case of our pilot specifically, so I will just jump into the next part. We wanted to analyze transport corridor And in our case, in the case of PKA Gdynia, there was only one operator operating within this transport corridor. However, we have a few public transport operators in Gdynia. That is why we wanted to analyze if only one transport mode would be the best solution for a specific transport corridor or not. Regarding our other activities within the project, you may see on the slide that we were having lots of different KPIs or data to be analyzed for the transport corridor operator, urban transport system, and also the city itself. However, our pilot was focused only on transport corridor and public transport operator, which was the PKA Gdynia, but also we wanted to analyze other scenarios for seeing if maybe the other public transport operator could be engaged in operating within this transport corridor. Regarding public transport in Gdynia, there are some specific features for Gdynia as a city. We have trolley buses in Gdynia in operation since 1943, and it's one of the oldest trolley bus system in Europe. Also, we electrified some routes and the electrification process is ongoing since 2022. And also we wondered if we should electrify more routes or not, or if the trolley bus, in motion charged bus or diesel bus would be the best solution for some routes we wanted to change and wanted to develop. So to sum up the features for public transport in Gdynia, you can see on the slide that we have e-buses, we have trolley buses, and combustion engine buses, which are dominating right now, but we are trying to change that regarding our goals for electrification of public transport. And also, of course, they are aligned to European Commission requirements. Going through the pilot method we developed and also we implemented in our pilot project, which was digital twin. Firstly, we analyzed the transport network for Gdynia, and together with our colleagues from KRUK, we implemented or developed first a digital model for this transport network. We focus, in fact, on transport corridor, not the whole network, since it was too wide scope to be implemented within our pilot, because as it says, it's a pilot, so we wanted to make some smaller sample and then see if we can implement this in some wider scope. So we developed the digital model, and then we validated different scenarios for the transport corridor planning, let's say, what kind of transport modes should be implemented within this transport corridor. And also then, after analyzing really a big number of scenarios, we concluded what would be the best solution for particular routes within this transport corridor, since within this corridor we are operating, or PKA is operating on separate few routes. So energy flow simulation was made for transport corridor, Western corridor, we called this like that. And you can see on the slide what was the part of the transport network which was under analysis. As you can see as well, current service is run by diesel buses and to a lesser extent electric buses, and we wanted to see if we should develop it in some way, especially if in motion charged buses are a sensible solution for this transport corridor, or we should mix it with diesel buses and electric buses in some combination, let's say. So the pilot started as the project started. So in September 2023, few months after starting the CE4CE project, we defined a collaborative framework, and also we determined what should be under analysis. Then we narrowed it down to just a Western Corridor, as I said, since we wanted to make the pilot for just selected few lines, few routes, and you can see also these bus lines in here on the slide. Later on, when these lines were selected, we developed digital twin for the selected corridor and the routes within this corridor, and we analyzed, as I said, many scenarios, over 200 scenarios for changing this transport corridor in different variations. And also we analyzed scenarios for no traffic, high traffic, but these were only just few variables we wanted to incorporate in this analysis. So we analyzed many options, and for these many options, you can see main results on the bottom of the slide. And the last part of the analysis is socioeconomic analysis, which we are ending right now, also using hackathon with students and experts to help us to validate the pilot results, because of course the pilot results are very reliable, but as you no, we have to also incorporate some socioeconomic analysis to validate these results if they are sensible in our situation or not. We analyzed these few routes for the Western Corridor, including their frequency, start time, offset, number of vehicles operating, but also we changed within the different scenarios we developed, we changed numbers from this specific, very primary table in order to see if something will change or not regarding our real life data we had at the very beginning of our pilot. So we assumed that some variables will be having some specific numbers and some specific values. As you can see on the slide, this is just some assumption we made within our analysis. However, as I said, many scenarios were developed, and for sure we will deliver also publication, scientific publication regarding the results and summing up the results for this very vast analysis. So we assumed some values for parameters such were contact wire, temperatures, modes, stopping times at stations, what was the passenger load, charger power, and number of vehicles charging at the charger positions. Also, we analyzed the current situation of charging stations within the city, and also, of course, potential situations, so situating new chargers within some locations within the Western Corridor. On this slide, you can see a part of the final analysis of our partner, Kruch Railway Innovations, this was only a part of the analysis for different scenarios, and for some situations we assumed with traffic or no traffic, with frequency 7 minutes, 15 minutes of operating on specific routes. So we had to analyze a few types of charging and few types of vehicles operating on specific routes. So you can see stationary charging in here and in motion charging with 3 options. Let's say standard charging, high power charging, or IMC plus. And we wanted to analyze different scenarios regarding all of these options of charging of electric buses or trolley buses or in motion charged buses on specific routes. So we had to analyze the situation for batteries, so how often we should change batteries within some lifetime of the vehicle. We analyzed battery costs and battery lifetime, battery degradation regarding stationary charging, opportunity charging, in motion charging, overnight charging, etc. So we had to analyze lots of different scenarios and combinations of vehicles on specific routes. Also, we had to analyze situation regarding frequency of using vehicles and frequency of operating on specific routes for these few lines I mentioned before, and you could see on the slide. So we had some trade-off appearing in here. So comparing costs of infrastructure and costs of batteries and vehicles and energy. You will see on the further slides some results for this analysis. However, lots of trade-offs appeared in here, and we had to analyze many combinations of vehicles, types of charging, and also analyze the costs of the lifetime for vehicles, separately for batteries and for infrastructure. So some of the scenarios are presented in here. I mean, one scenario for 7 minutes frequency and high congestion. It is one of the most probable scenarios we analyzed within our pilot, because we know that the congestion is appearing specifically in some hours within the daily cycle of operating on specific routes, especially mornings and afternoon. So we wanted to analyze the very similar to reality scenario. That is why 7 minutes frequency and congestion was one of the most probable ones we wanted to analyze and incorporate in the final results presented in our deliverables. So on the final table on the bottom of our screen right now, you can see stations like Centrum, Kielecka, Chważno, etc. So these are stations, and then you have in the first column of the table lines of buses operating right now, and also in the main body of the table you can see different options. So opportunity charging, in-motion charging, plus or standard, or the third scenario presented specifically in here, so high power charging, right? So you can see different combinations of this charging scenarios, let's say. So as I said, we analyzed many scenarios in our analysis, and we had to make some assumptions regarding what we exactly want to optimize, because as you probably know from some econometric analysis and statistic analysis, always one variable is this dominating variable to be optimized in every simulation. So we assumed minimal costs of particular variance regarding frequency and traffic conditions for the Western Corridor, and analyzed different frequencies and different combinations of vehicles on the route. And what you can see on the right-hand side of the slide are just summary, very general summary of our analysis for 15 minutes no traffic, 15 minutes delay, so traffic, and also 7 minutes without traffic and 7 minutes with the delay, so in the situation of high traffic on the route. And also two options, so electric bus and in-motion charged bus. And we analyzed what are the costs of every option, and also analyzed these costs regarding energy, regarding vehicles, and regarding using batteries. Also regarding batteries, we assumed 2 times replacement, or replacing 2 times batteries within the life cycle of the vehicle. However, we are aware that it can be the other way, so not necessarily 2 times they should be replaced, maybe 1 time within the life cycle. However, we wanted to analyze the most strict or most negative scenarios as well. That is why some assumptions are very strict, and that is why also some combinations of vehicles were presented in the final results for 2 times replacement of batteries in entire life cycle of e-buses. So you can see on the right-hand side that regarding 15 minutes or 7 minutes frequency of operating on specific routes, we have the cost in €1,000 lower for in-motion charged buses. For all the scenarios, in fact, we analyzed, but with this assumption of 2 times replacement or 2 replacements of batteries for the e-bus in its entire life cycle. Slightly different, it was presented for 1 battery replacement. So in fact, our pilot was focused on simulating different scenarios, and what you can see on the slide is one of the probable scenarios which may be observed in future in reality. However, our pilot was focused on simulations, and we wanted to train the model regarding the data we have and regarding the objectives we want to reach or target to be met in the future. So that is why we assumed many scenarios, and of course they are having different probabilities to be observed in reality and in future. However, what we wanted to present to the wider audience was that digital twin is a very good solution for decision-making process for a public transport operator, not only for 1 route, but for the whole corridor or combination of routes in some geographical area within the city. And also we wanted to train and then later on share with other public transport operators how to make digital twin, if it's difficult, if it's not difficult, how long it takes to gather all the data, what data should be collected by the public transport operator to prepare good analysis with the use of the digital twin. And the digital twin itself together made by University of Gdańsk, by PKA and Kruch, showed that this kind of decision-making process and the tool as a digital twin is the tool for enabling and supporting decision-making process. This is really good solution for public transport operators, since you are more than sure that your decision is good regarding planning using specific kinds of vehicles on specific routes. And also you can analyze as many scenarios as possible within the data collected, the data you have as a public transport operator, and you are secured in your decision-making process more than, let's say, normal, usual statistical analysis or simulation. So for sure, in our case, EFS facilitated operational economic analysis and helped us to decide what should be potential investments on specific routes. It is now more precise. We are feeling more secured in the decision-making process if some routes should be electrified and in what way, because that it should be electrified. Sometimes you are sure, but in what way it should be electrified regarding cost of investment in the infrastructure vehicles, and what kind of vehicles should be chosen for a specific route. And really, digital twin is one of the best solutions, and we are sure and we can recommend you this digital twin as the tool supporting a decision-making process. So in Gdynia, digital twin was the best solution in our decision-making process, and hopefully for you as well, our dear participants in our e-course, it could be also the best solution in your decision-making process. So if you want to know more, please feel free to contact us in future. Thank you very much for participating in this part of our e-course, and hopefully see you again in future. Thank you very much.